Welcome. We are here today to talk about Nova 2 Lite. How many folks here have tried out Nova 2 Lite since its launch like less than 7 hours ago? Okay.
You didn't leave the keynote and do it immediately?
Yeah. This might be the first workshop where we do that. I'm Pat. I'm a solutions architect with the WWSO Bedrock go-to-market team, and I've been working for the last year with Gene on Nova.
And my name is Jean, so I'm on the Amazon AGI team. I am a senior solutions architect. So happy to be here with you guys today.
Yeah, and I'm glad the badges work too. So congrats on getting in. We're going to cover a lot today, and we have a rough agenda. But if we're doing this the right way, we're going to be doing a lot of coding. And unfortunately, some of it will be mostly code review given the difficulties here, but we're going to go through a lot. When Gene and I were first planning this, we had a very tangible, bite-sized idea, and we quickly realized this is a huge problem. So to solve this at scale, to build a fully autonomous coding agent, has a lot of nuts and bolts. We're going to talk about all of that, but I want to set the right expectations here that we may not get through all of it, but what we want you to see is how you can prompt Nova 2 Lite, the major considerations to make if you're going to do this at scale, and any of the stuff Gene's going through or I'm going through. Make sure you ask questions. We want everyone engaged. I know it's a large audience, but that's always the best way to do this.
Yeah, question. Show of hands. How many people have actually done a code talk before? Are we familiar with the format? The goal for this is we're going to be in the code and we're going to be very interactive. We want to be talking. We want to hear, the questions that you have as you have them. This is not a 10 minutes at the end Q&A. This is a conversation we want to have with everybody. So it might be a little bit different than all the breakout sessions you've gone today. It's really, really scrappy. We're going to be in the code and we're going to be talking about the model.
Cool. And I have Leon and Caesar, who I've voluntold I can call on, which is great. Does anyone else want to be called on? I figured that was the answer.
We'll get you talking in a second, don't worry.
So let's talk about Nova 2 Lite. So Nova 2 Lite was announced today. It's a large context window reasoning model. It comes with built-in support for our system tools. You'll get to see some of that at work here. It's our next generation of Lite. We've also announced Pro 2 and Omni that are on the horizon in preview. But today we're using Nova 2 Lite exclusively, and we're going to walk you through how to use reasoning, how to set budgets, and how that impacts code generation. Anything you want to add there?
No.
So where Amazon Nova 2 Lite fits in, like I said, it's got a 1 million context window. It's actually got 64,000 token output. So if you are using reasoning, you will eat through some of that. But the output of the model we've seen perform really well. Oh, sorry, I'm on the wrong screen here. And it supports all the languages we've supported thus far. We're seeing it do really well at translation tasks. You can use it to fine tune. We'll talk about why you might want to do that for code generation use cases. And yeah, we'll go ahead and get started into code. Gene's going to get started on building out this coding agent. Feel free to follow along in your notebooks if you want.
Awesome. Yeah, you want to switch me over to?
Yeah. Okay.
Nice.
We'll walk through some of that today, yeah.
Another question, this can just be a show of hands. Is everyone familiar with strands? Okay, some people are. I'll give a little bit of an overview, but I'll make sure to cover what's important here. What about MCP? Model Context Protocol. Nice. That's a good amount of the group. Has anyone built an agent using an MCP server before? Okay, pretty good. So we're going to be using MCP today as well to talk through this. So to set the scene for where we're kind of going to start and how we're going to build, we are going to have a GitHub issue that we're working with. The problem, it's a little bit meta, but yes, question? Yes, I absolutely can. Okay, so I am in a repository. So LangChain AWS. So LangChain, We have our own dedicated kind of sub-repository for the AWS integration. New model was released. We want to make sure we're integrated well and that we support all the new features of the model. This is kind of our meta problem we're going to talk through today. So starting with an actual kind of GitHub issue in using a real repository, right? We're not one-shotting an entire application. We're in a real repository with real code that serves a real business function. And we're going to start kind of iterating on what it looks like to actually interact with that. How do we get the model to understand the context of the space it's working in? How do we get it to solve real business problems in a space that has been around for a while? It's a real code app. So I'm going to be using strands. The kind of high level, if you're not as familiar, it's kind of like LangChain, except it's our version and has really great integration with AWS services and tools. So it means that our models and kind of other things that we've been building on AWS, they all really play very nicely together. And so I'm going to be using that today to supercharge, really get started with building this agent. The nice thing is you see with like a lot of these agentic kind of frameworks that you can use, they do a lot of the code pieces for you, so I can get an agent going in a couple lines of code. And what I want to start with is just what happens if I prompt the model, right, with, look at this issue and comment on the issue with your implementation plan. This is extremely vague. I'm not giving any context at all. All it has is the GitHub MCP client. Now, we're going to clear this out. And I'm going to, spoiler, I will be going to a different script to show you a little bit later. But we're going to run this. And we're going to see what happens. And I have some boilerplate code that should be making this a little bit nicer. And I'm going to zoom in because I'm sure you can't see it. It's not as pretty when I do that. I apologize. But what's happening here is the model is starting to call tools. So the GitHub MCP client, if I go and just open up my Python, I want to make sure you can see it. I'm going to import the client, and we're going to initialize it just in a Python execution. And the goal here is to show you what the model is seeing behind the scenes. So we put a one-line prompt, and I initialized a GitHub MCP client. So GitHub, right, they provide a couple ways that you can use their MCP server. We're just using their remote URL one. And we are...
Could you take 15 seconds to explain what an MCP is? So I'm still...
Yes.
Absolutely, yeah.
Yeah, so MCP stands for Model Context Protocol. It provides a uniform, kind of standardized way to interact with arbitrary servers and things like that, and to allow agents to really build with them very easily. So instead of you having to go and implement every single API that's going to interact with GitHub, you can use their GitHub MCP server, and now I can go get issues. I can make changes to files. I can create a branch. I don't have to implement any of that myself. They've kind of created this standardized interface for me. And
GitHub released their own MCP. Many companies are. We're going to see how you can use it, how you cannot use it, but it's going to be one of the first tools you're going to want to consider when you're rolling out a coding agent of any sort. AWS also has MCP servers for like all the announcements today will go into our MCP server. So if you're building agents that need to use the latest and greatest, you can make a tool to go look that stuff up for you.
Okay. And you watched, okay, so basically, if anyone was really watching me stumble for a second, when I am interacting with the GitHub MCP client, it took me a couple lines of code. And this is all of the tools that become available to me. I can get a comment, add a comment to a pending review. I can get team members. I can get a commit. I can assign a copilot to an issue. Maybe we don't even want to do this code talk today, and we'll just say, GitHub Copilot, go do this for me. Right? And so you have these standardized ways that you can start interacting with GitHub. But what's kind of tricky here is this is really nice, and this is really easy for me to get started. But I did a couple lines of code, and now I'm passing my model 40 different tools it has to choose from. That is a lot of context the model immediately has and has to decide what tool to use. And there's a lot of kind of things that come into play here where it's important to be intentional. It's a very nice thing, but it's easy to get things a little out of hand just to begin with.
Because remember, the model gets passed like a giant tool config, right? And the model has to decide, of these tools, which is the most relevant for what I'm trying to do. So if you give it 5 very well-selected tools,
right,
it's going to have a better chance. You're not going to eat as much context window. If you give it 20 or 30, you're really making a big bet on the model's ability to traverse long context and pick the right one. Nova 2 Lite does it well, just going to say. But what she's trying to say here is that's a consideration to make.
Yeah, and I think you'll see a lot of guidance for like all model families. And once you get above 20 tools, they usually recommend breaking things into sub-agents, exploring multi-agent architectures. It's a kind of a really important consideration that you want to make. And what you definitely need if you're going to do that is a good system prompt to give some guidance, right? I didn't have any system prompt. I just said, go analyze the issue. And I am not going to lie to you, it did OK, right? It read the issue. It added a comment. It made an implementation plan. And I would like to pull up the issue, make sure my internet, let's see what it said. Right, I'll implement support for this. I'm gonna make a couple steps. This is all pretty reasonable, right? With no instructions, just providing the context of the tools. It did something that I think is like pretty fair. What might stand out to you is this is all very vague. It didn't actually read any of the files, right? It didn't actually go and start exploring the repository. It read the issue, made a comment, decent plan, but it's not what I want it to do, right? If I'm going to build a real agent, I want it to look at the files. I want it to actually be interacting with what's real. So what we can do next is if I go back to my Strand agent, I want to use this new template. And I'm going to take a second here to talk through just some best practices with Nova 2. And I think a lot of kind of complex agent prompts that you'll want to build overall, and I'll zoom in. You need more than just a simple prompt. And the first line might look pretty familiar. We're providing a role. You do this for like every agentic application or any LLM application. But we need to take it a step further. So a couple things that we have trained our models to be good at are these specific sections that you can use to draw attention to specific pieces and workflows and business processes. So the first one is core mandates. This is the important business rules that you need the model to follow. So one, right, I don't want you to update the original issue. Don't edit it, just add a new comment. Another one is the actual workflow you want the model to follow. Right? I want you to get the issue, but I want you to explore it. I want you to go and look at the files. Nova does really well when we pass the tool names that we want it to use. It really draws attention, right? It links to the tool configuration it's seeing. And then I'm having it return the plan in a specific format. I have in the output formatting. Output formatting does really well when it's at the end of the prompt. The next section is tool usage. So you might wonder, OK, we're passing it, the tool configuration is going to go to the model. What else would we really have to specify? And tool usage is where we want to put the important business rules for us for how we call the tools. So MCP is great. It provides a standardized interface. But how we want to use the tools is going to change based on every single use case that you're going to have. So this is where you kind of bring into some of the specific things that are the most important for you. I always want to make sure that we're reading the issue, providing some kind of tips around how to interact with the file paths. I'm encouraging parallel tool calling. Parallel tool calling is when we want the model to call multiple tools in parallel instead of waiting for one after the other. So kind of encouraging that behavior.
Actually, I want to pause there for parallelism. Is this a parallel invocation of the model that's occurring when you're asking it to do that, or is it?
So what will happen is the model will, in one single assistant response, it will have 2 tool calls in it. And so this might come up, and where I would hope to see it, if it's necessary, is, let's see the contents of multiple files at the same time.
Awesome.
So that's kind of a behavior that I'd like to encourage. And then the next thing is around error handling, right? It's very nice to assume that everything will work perfectly all the time, but when you're using MCP servers, when you're using tools and agentic workflows, things break a lot, right? Something's going to time out. I might do, something else wrong, right? And so you just want to start to that's the focus of that section, is how do we want it to respond? If I time out, do I want the model to try again? Do I want it to respond gracefully and give up, fail quickly, right? So this is kind of where we would start to think about that section. So I am going to now run this again. I'm just going to pass it in the system prompt. Here, no other changes necessary, right? I'm going to keep the prompt exactly the same. And we're going to run it again. And we're going to look and see how the model changes. What I'm hoping to see, we still should read the issue. I'm hoping the model will start actually looking at the files, right? I'm hoping it's going to actually start kind of exploring the repository. And fortunately, that is what I'm seeing. Something you might notice, though, it's going to be a little bit slower than it was the first time. Why is that? Right? It's going to have to make a lot of tool calls because it doesn't have any context about what this repository looks like at all. It has no idea. So what is it going to do? It's going to guess and then try to start exploring and figuring this out. And a lot of models are very good at that. And it's something that if I am doing my own kind of day-to-day job and I want to connect to arbitrary repos, that's fine. But if I am building a coding agent for a repository I know it's mine, we can take advantage of that, right? We don't have to make the model explore by itself all of the time. You can see this is just slow, and I don't blame the model at all. It's going to be searching for a repository and exploring and iterating. It's fine. So this is where we get into this optimization opportunity for context. So the Nova models, like Pat mentioned earlier, support a 1 million token context length. So I wouldn't blame you if the first thing you thought about was, why don't we just dump the entire code base into the model context? That seems easy, right? I'll pause here because we got the output, but you can see 8 tool calls. It did great. It read the issue. It explored a lot of different files. It added the comment. And I can even, we can see here the quality that has improved just on our system prompt. We're actually looking at specific code changes we want to see happening. It took a long time to get there, but it got there. And now we have real code that is actually going to be usable and relevant to our own repository. But I want to improve on this because I'm not a very patient person, and I think that we could do it better. So
real quick, though, any questions on what Gene just went through there? Yeah.
Yeah. So when you added these tools to your agent, right?
Yeah.
I might have missed it, but did you specify a few tools because you said you didn't want to pass all the tools?
So that's a great question, and it's actually going to be one of the optimizations we're going to make a little bit down the line. At first, I am just passing all of the tools. I'm passing all 40 of them. And you can see, like Pat mentioned, the Nova models, we tune them for agents. It does well with 40 tools. It did the right tool calls. I'm happy with the decisions it was making, but that's a lot of tool calls. And I think the first prompt, where I just have one line and all of the tools, it adds immediately over 8,000 tokens just in the tool config, which is helpful context, but it's a lot, and it's unnecessary. And so that's one of the steps we'll take is kind of shortcutting that and being really intentional.
Yeah, and the quantity of tools is actually a good place to start if you're trying to now make multiple agents, because then you can compartmentalize your tool use. It's associated with a behavior you want out of the agent. So it's a good place to start if you're moving into multi-agent architectures. Did someone else have their hand up? Yeah.
So I'm using GitHub's hosted MCP server, which so they have one that you can self-host. It's just a Docker container. You can run it locally. But they also have one that's available just through an API endpoint. So that's what I'm using today. Definitely recommend if you try this at home and you make your GitHub token, be smart about the permissions you put on your GitHub token. I've done some crazy things. So learn from me.
We're gonna push to the LangChain repo today, right? Just kidding, we're not gonna do it.
So I.
Yeah, you got suspicious when asking not to alter the original poster.
Yes, I did. You caught me there. And then one time I wasn't following my own, our own security best practices, and it was starting to push to the main repo, and I was like, no. And so I made a protected branch, and then I was, intelligent. But it's fun to play with this stuff and see what happens. It's fun to break things. So
and tools are an implicit security boundary too. Sorry, I know you want to move on.
Yeah.
But like, if you don't want an agent to ever do anything associated with a tool, you don't give it the tool. And when you're first iterating on things like we're doing here, you'll find those rough edges really quickly.
Yeah. So I think there's some. I guess I went a little bit on a tangent there with the tools and everything that was happening. Going back to how we take advantage of the context length, I do want to show what happens when we pass the entire code base. I think it's a very natural path to take it on, especially when we have repositories that can handle that much context. And so I have I wrote some, a script, I dumped all of the files. I'll call out, I'm using some of our best practices we have for how to format for long context. So I'm going to be breaking up the documents in a specific structure. I will call out, I did not do something very nice to the model, which is instead of passing the path that is going to be in the GitHub repository, I used my local file path. So not really making it easier, but at least providing some context, right, to the files and the content in the repository. So what we're going to try to do now is I'm going to actually put this in the prompt, and I believe I called it code base. Text. I'm going to say format, repo, content, and we're going to just put this now at the top, which is another best practice for long context. You'll want to put that at the top of your prompt. And we're going to now run it, and we're going to see what happens. And I'm going to call something out that you might pick up on really fast. One, it is a lot slower. We're passing an absurd amount of tokens through. I was smart. I ditched the UV lock and some other stuff that just threw it right to the context length. It's going to be about 500,000 tokens. But that's going to be on the higher end, right, of our token context length. And there's a lot of papers around this topic. So we can take advantage of the context length. We train for long context. But something that is kind of seen across all models is performance of the model degrades as the context increases. And aligned with that, when we do long context, a lot of times it's usually best when we're looking for something very specific, right? It's a needle in a haystack. I want to go search for something in this long, huge amount of context. Models are very good at that. But what's important for when we're doing code is semantic connections and how are things playing together. And that you don't get as much when you're just dumping everything into the context. And so the benefit doesn't really, of having all of it, it's a little bit tough, right? What we're probably going to see is still very good outputs. It's probably going to call less tools, but it's a lot slower, and it's going to cost a lot more.
And we've seen customers now with navigating the dependency of a software project take this in a whole direction unto itself, building a graph of dependencies so you can look up dependencies using a query. There's a bunch of RAG efforts that can go into making this specific part of a coding agent more efficient. But yeah, hopefully you got the results. So I don't
Yeah, we'll notice a couple things, right? Less tool calls, so that's kind of nice. I had to do less steps. Maybe that saves us a little cost. But I'll call out what stands out to me when I see this immediately is that it didn't add a comment like I asked it to, right? The performance of the agent decreased with all of it, with all of that context. And the quality of the code is still great. But for agentic workflows, there is a big trade-off here, and you want to be really intentional because of this about managing the context. And what we see a lot with coding agents is you can run through your context so fast. And you don't want to basically shortcut that by adding a bunch of context at the beginning. You want to allow for the context to build up naturally and have more proactive compaction strategies throughout the period of the agentic workflow, right? We don't want to just kind of, basically handicap, right? Put the model at a disadvantage just from the beginning.
How many folks are using Code Assist in their IDEs? Just any sort of, oh, you're willing to admit it. That's awesome. I do too. So what you noticed a lot with Kiro, with Continue, with any of these plugins, they're very surgical about how they look at files. So they'll go search for something in a file, and they'll take the line numbers, and they'll put that into the context. And so just to highlight what Gene's explaining here, that's for context management. They're getting very specific about the things they put into the context window. Yeah?
I was actually going to ask about that specifically. So how does it not have the context of the full file and the whole code basis? How is it able to search and look for files?
So,
Specific lines if it doesn't have that whole context already?
So my proposal to you all to do, and what you'll see if you really get into the nitty-gritty of how a lot of these coding assistants will do is, they will use the repository structure in the context instead. So one of the benefits, right, of the fact that we as humans have been working in code bases for so long is we try, hopefully, to design them in a way it's intuitive and easy for us to navigate. So now we have the ability to just take advantage of that. It's designed for us to be able to navigate it, I hope, if you're lucky. I've been at companies where maybe we're not as good about that, but you have human preference tuned file paths that provide context out of the box for what is probably going to be happening in the file, and you can provide that to the model, and it gives it a starting point of where to look. And so what I have now is a separate text file that has all of the file paths in the entire repository. I'm not, at this moment, providing any additional context to it, but I'm providing the file paths. And you can see here, I think the thing I called out in the issue itself is add something to the chat bedrock converse class. We can see here we have this file path that says bedrock converse. It probably is going to give a hint to the model that, oh, that might be a really good place for me to start looking. And so if we switch this out now, and we just instead pass this new text file that has the file list, and try to run that, we should see a couple things. Ideally, the Wi-Fi holds up, right? It's just going a bit faster. We should still see a pretty high quality output from the model. And so this kind of really easy tuning, to be honest. It wasn't a very hard script to write. And so this helps us kind of very easily provide context to the model. And while that's running, I will show the fact, the next step that you can take it is actually sorting the file paths and stuff. And if you are willing to put the time in, this is another way that you can be a little bit more intentional about providing the context to the model. And a lot of, what I've noticed, a lot of repositories that want to be really easy for agents to work in, they'll provide this kind of stuff in the agentsmd file and things like that. And so it's being a little slow. I will say, I'm going to blame the Wi-Fi. But so far, we've only had 2 different tools that are going to be called. We're getting another file contents, and so we'll see what the output looks like. And what I'm hoping for, right, is we'll get a high-quality output with the implementation plan.
And so one thing that to keep in mind, because agents in particular are token hogs, right? We know they use a lot of tokens. Code bases will eat through those tokens faster than you can blink an eye. So the other reason to be conscious about how many tokens you're using in your contest window, how good your tools are, is because that's a measure of cost in the long run. So if you're running this agent for every single issue that gets submitted and it's running autonomously, you know, there's a consideration for cost. We'll see the output tokens here, but it's considerable. We're only doing a pretty straightforward.
Yeah. Yep. And so we can see the output now. We had a significant reduction in the tool calls from the first one where we provide no context to the repository. We also, in comparison to the one where we're passing the entire code base, right, this is a lot more reasonable on the input tokens that are going into the model. And then the quality still of the output that we're getting is still very high. We're still going to be making very specific code changes that were targeted for the files that will, you know, have the impact that we want for the GitHub issue. So this is all good things if we're thinking about a autonomous coding agent in terms of planning, right? We're going to do a long horizon coding task. We want high quality planning at the beginning, right? If you're using a coding tool, you want to plan and then you act. It's the same when you're building it yourself. We put a lot of time into building a high quality plan. This is only so helpful because at this point, nothing's actually writing any code. I still have to go implement the plan, right? We want to build on this, and we want to actually build something that can take actions in the code base. So the option for us, we have 2, basically. We can either continue to build on the current agent that we have, or we can start to expand upon a multi-agent implementation strategy. Now, there are a lot of cons with a mono-agent architecture here. And we're being really repetitive, but a lot of it comes to the context. We're going to put all of these tool calls and context just to create the plan. All that really matters from the plan is the output of the plan. And then if we build on top of that, we're still tracking all of the tokens that we use to get to the plan to then act and actually build it. So what you'll see in a lot of the coding agents and kind of the direction we want to go now is a multi-agent architecture. And we will start with using strands still, and we're going to implement it using a graph-based approach where we will have a planning agent and then an act agent. Our plan agent, right, it will do all the tool calls to look at the files and determine what needs to happen. And then that output will go to our act agent. The act agent will take the implementation plan and it will actually start iterating and writing the code. So the direction we've been going so far, you might assume we're going to use the GitHub MCP. So one thing you might pick up on and I'll call out is when we use the GitHub MCP server, every single tool call where I'm getting the file contents, I am getting the entire file contents from their API. It's a lot. It's quite slow. And then if we do the create update changes, we're also outputting the entire file through a tool call back to the server. So it's very, very slow and not necessarily the most practical way to do it. But we'll get to that a little bit later, a little bit of a teaser. So we'll try it out. So I have 2 agents, like I said. I'll just show very quickly in strands, if you've done a graph approach before, what you'll do is you'll create this graph builder. You'll add your nodes, and that's really it. It's quite easy.
Is everyone familiar with like the basic agent orchestration patterns? I'll go over those really quick if that helps. So the most ubiquitous pattern right now in agents is the manager agent and the sub-agents. The manager agent dictates when and who it calls to get work done, and it decides when the work is done. Absolutely a thing. There's also graph agents. You can think of it as a left to right graph in our case for coding, where every agent is a dependent on the previous node. They call them nodes. That's also, there's different names for it. Crew AI has its own terminology. Strands has its own terminology. But the idea is that the agents are moving left to right, and once they move to the right, they don't come back. So in code projects, you typically have that. If you've used Kiro, it feels like a left to right process, right? They have a requirements doc, or a design doc, requirements, and then implementation, and then unleash the agents and do the things. So those are like the two most ubiquitous orchestration patterns. Yeah.
So are all the agents in the group chat and based on the annotations, the manager will know what to assign? Or?
I'm sorry, I missed that.
So is Trans doing like a group chat of the agents behind the scene where they're all talking to each other?
A group chat? That'd be cool. No. Essentially, what's happening in a graph agent orchestration is when the agent's done, you can send the result of that agent to the next one, and then it picks up where it left off. You can send state to it. You can propagate the input from the original all the way to the last agent. But no, they're not commingling and talking about things. That would be more of the manager agent orchestration. You can ask it to do a whiteboarding session, update a markdown file with your ideas. Let's take votes based on what you think of what's been proposed, stuff like that. Yeah, the manager agent says, and this would go in your prompt, right? You'd say, you are a manager agent, you're assessing the work. You have a implementation agent, it's responsible for this. You have a coding agent, it's responsible for this. And you're relying on the reasoning ability of the model to decide which agent to work with. So you're leaving that completely up to the manager agent.
So I have it running. I'm actually not even going to let it kind of continue all the way just because we only have 20 minutes left and we're going to get to some really cool stuff. But the message I want to give here is we're able to switch into this multi-agent architecture. We still have a disadvantage because it's still really slow. And so the path that we want to talk through now, that Pat's we're gonna take over a bit, is how can we build this more locally centric? How do we create an environment that we can actually make the code change and test the code changes? Because that's going to be a lot more practical for these kinds of applications.
Let's do it.
Let's do it.
I'll have to show you what I wrote, which I know isn't as exciting, but we've had my laptop doesn't connect well. So I've neglected this side of the room. I hope you're all getting as much out of this as I hope you are. So let's talk about a couple quick concepts. So when you write code, you never just write it and then and then push it. I mean, some of you might be that good at writing code, but you've got to make sure it actually executes and it actually does what it's supposed to do. And we take that for granted as developers. We run the code, we write a test, and if it works, it works. If it doesn't, you write more unit tests and you keep iterating until it's done. So how do you get an agent to do that on its own? Because it doesn't have a workspace. Well, you give it a workspace. What I'm going to talk about now is how to maybe do that with code execution. How can you use Docker to create a workspace for this agent to put some files in it, mount it to the image or the container, run it, see what happens, get the exception, and keep iterating. And this is something that we're seeing a lot of folks do. They might have a container image that they've baked for their pipeline that they want to use. Those are great candidates, by the way. We're going to show you a really simple example in Docker. Before I go there, let's take a look at that tool. So I called it the code execution tool. By the way, in Strands, as long as you're doing things and following the rules, anything you put in the tools directory can be sucked up by the agent without question, right? That's good and bad, because if you've got hundreds of tools, that gets to be a problem. But just if you're building agents for the first time, it's a good way to get started. Code execution, I'll walk through a few things here. Oh, you have your scroll reverse, okay. Not reverse, it's the right way. It's the right way to scroll. So what I've done here, and I've just hard-coded a default workspace path, but what's gonna happen here is I'm gonna tell it, put all your work in this Docker workspace. If you're gonna clone anything, if you're gonna write any code, make sure it goes in there and put your tests somewhere else, and you make sure that we're keeping these things separate. File system security and network security are also a thing, right? You don't wanna, if you go deploy this and you let it ping the internet, go pull down any library it wants, completely unvetted by your security team. These are all super important considerations to make. Anthropic in late October released Sandbox Runtime. I would highly suggest taking a look at it. They've, I think in a very thoughtful way, offered a great tool for solving that. You can send all your traffic to a proxy if you want. If you don't want this agent doing anything else, you can lock down the files or the directories it has access to. We're not going to get into that today, but I wanted to put that out there. There's also Agent Core code interpreter that is designed specifically for this use case. So my execute Docker tool, just like all tools, you want to give it good descriptions. Again, remember the context. All of that goes into the context. Like when Strands picks up the tool, it's picking up the description to help it decide what it's doing. I got a little carried away here, but it's important to remember that. I'm sending it back a return error if I don't have the right information. Dependencies. So how are you going to tell the agent to, like, if it needs to do a pip install or it needs to, like, get the environment ready before it executes the code? You need to tell it where to put it. So requirements.txt is going to be a really important thing. I'm using Python, so of course, if you're using Node or some other language, that's going to be n number of steps to complete, as we know. But here we just got a simple Docker command. So if I have all the requirements, I'm going to include the requirements doc. If I don't, then I don't. But I've pulled down a container image. I'm telling it the workspace to use, and I'm gonna pip install everything before I do a single thing, before any code runs. So I have parity with my test environment, my prod environment. So you can imagine, you probably wouldn't do this for reals. You'd probably have a container that's hardened and everything. But we're moving fast here. Any questions on this approach? Any worries about doing this way? Leon's like, yeah, what do you think?
I'm interested in the results.
You want to watch it just explode? Yeah, so files, yeah, go ahead. Oh, yeah. Yep. The question was, how do you prevent the agent from downloading packages that are either like not approved or are not from your artifact repository, which is what most enterprises are doing. That's where you'd want to give a lot of thought to locking down which addresses it's allowed to use. And that's why using a proxy is good. Sandbox Runtime lets you say, only allow anything to this domain. If it's going anywhere, it has to go through this address. That's one way. You could create a separate tool or a separate agent to like prepare the dependencies, do it in a secured manner, get the trust of your security department, and maybe they manage it, and that's a way to do it. There's a lot of angles you could take, but yeah, it's worth thinking about. Yeah. Yeah, she asked, it's just in Docker. It's probably not going to go anywhere. No, it's probably not. But Docker is leveraging my network hardware, right? So we get to hand wave that. Yeah. But if you're launching or spawning a container in like an ECS cluster, that's going to be managed for good reason. But you wouldn't want it reaching out through your NAT gateway and just like pip installing whatever it feels like pip installing, because I can tell you it'll end poorly. Did you have a question? Okay. Cool. And so this executes, runs the Docker command, and then returns. And again, I'm sorry, we had this while working, but we can't get this laptop working. It returns errors if it doesn't work. Okay, so code execution. I'll show you the Docker file I've written for this, if that helps clarify. It's roughly what you would expect. You're setting the work directory to Docker workspace. If your code has to create things and has to persist things, that's a consideration too. If its task is to actually output more code or output artifacts you need for some other process, telling it where to put it is also important. Go put it in S3. You could put it locally, but then when the container dies, you lose it. So these are the same considerations you'd make in any serverless architecture. But yeah, in our case, a very simple Docker file. Okay, I'm going to show you how we've proposed, in this case at least, you build a multi-agent that does this. Is this multi-agent one mine, the red one? The one with errors?
No, I cleared them.
Okay.
I staged the commit.
Got it. Okay. And I don't know if you've seen this yet. And I actually, why don't we go through this? Oops. Yeah.
Is all this going to run on our local machine, or is this running in the cloud storage? So if I'm running VS Code, and this is the coding agent using this, is this going to create a container locally on my laptop, or is this in the cloud?
Yes, for this very trivial coding agent example, we're just using the Docker runtime on your desktop. Yeah, but
Where might you want to host it on AWS?
yeah, you might want to host it on ECS or Fargate or whatever favorite container platform you're using. Remember that when this is running in a CI/CD pipeline or it's running in GitHub Actions, you've got to orchestrate where that compute and that runtime occurs. Yeah. Does that answer your question? Okay.
Yeah, because I think when I imagine kind of some practical applications of this kind of use case, right? We have coding agents that run locally all the time, right? So it's, why would I want to do this? I see the benefit here actually running in your a GitHub action or things like that. You want it to be able to kind of spawn in a place that's not local all the time. Obviously, we have 1 hour. That would be crazy cool if we could talk through all of this in 1 hour, but
yeah, we're gonna try. But we have 10 minutes left, so I'm going to keep going, and please raise your hand for questions. I want to show you how to actually. I don't think we've gone through how to actually make a request to Nova yet. So we have a model helper here where we're wrapping the Strands Bedrock model class and putting Nova 2 Lite in there. For a lot of heavy reasoning tasks, like if you're traversing a big context, you're going to want to actually use reasoning on high.
Right, because I mentioned this in the keynote session today. The Nova 2 Lite model we're specifically talking about in Pro and Omni that are announced in preview. They're extended reasoning models, so you can turn reasoning on or off. It defaults to off. And then you might, if you're familiar with using other extended reasoning models, you might be used to setting budget tokens or something like that. We do it a little bit differently. So we have reasoning budgets. And so we group them into 3 categories: low, medium, and high. And so they'll use a different amount of tokens in their reasoning. And so this is kind of t-shirt sizing that you can use to control the amount of reasoning that's done. And don't always think that more reasoning is better for obvious reasons. Output tokens. Reasoning high can use up to 32,000 output tokens. So we can imagine really complex problems. It's a really cool thing, but it's cost and time.
Yeah, and we've actually found if you use too much reasoning, that is a possibility, and the outputs can degrade. So something to keep in mind.
Yeah, question?
You have just one model deployment for all of the previous agents you were paying, correct? So now you have show 4 model.
Yeah, these are just different configurations of the same model for helper, just to make things a little bit easier. The question was just if we had 4. Previously, I was just using reasoning medium, and so I was using the same model.
And all the agents use that.
Right.
Yeah.
And now, you can also, I think it's a really good question too when we think about multi-agent, because you can tune it for the actual task. Maybe you want to have more complex reasoning for the initial planning phase, and you want to do less reasoning for the act, or the validation, you don't need that much reasoning if you want to add that at the end, right?
Yep. Sorry, I'm trying to make sure I get all the hands. Okay, let's talk about, where was I, with the actual agent here. So we understand roughly how the tool would be orchestrated so you can get code execution. In this example, I've taken the liberty to make a create enhanced plan agent. So some of the bottlenecks that Gene's example ran into was, how does the model even know what the repo structure is like? Well, now we're getting into like basic file system tools, right? So any of these IDE tools that you're working with, they have show me a directory tree, show me the first 3 files, show me the first 100 rows of the file, look for anything in the file that has this in it, then expand and give me like the previous and following 20 lines. So you very quickly find yourself you have to build those tools for the agent to use. Because like we said, you can't just dump the 15,000 line Python files into the context and expect it to perform well. It's going to be expensive, and it's just not going to be accurate. So you very quickly find yourself building tools that the agent can use. And so what we show here is we have some file system tools called show directory tree, get directory summary, like how many files are in this thing. We are using some Git tools. So as you move into off of GitHub MCP to your local workspace, like any developer actually does, you're going to want Git tools. And that's scary because you can do dangerous things with Git. But in this case, all we're doing is clone. So we're just cloning the repo. We're cloning the repo down, and then we're telling it, hey, use these tools to like explore. Tell me, do a code analysis, read the issue, and tell me where I should be making changes and how.
Like one question I'll throw in there too, I think it's like worthwhile to explore. I'm just going to call it out there, right? We're no longer passing the entire GitHub MCP tool config, all 40 files. We're narrowing it down. Right? You can see he's saying issue read, add issue comment. There is still value to using the MCP server. Those tools provide a lot of utility, but the ones that are going to require a lot of data, and everything that's passing through and can have, this benefit, we can take advantage of the local code environment, right? It's better to use the tools, right, that Pat is talking about.
How many have built file system tools or anything for their agents and gone that far? How has it gone? Yeah?
We never thought about doing everything remotely, so the first step was always clone the repo.
Mm-hmm.
I didn't even think about grabbing specific parts because I thought the model wouldn't have any context.
Yeah, and even so the other step you could take is, we were talking before, like a lot of repos have a contributing MD. Tell the agent to take a look at that. Until superintelligence is here, all of these agents will be coupled very tightly to the repository they're associated with. That's just inevitable. You're going to have to prompt it on guidelines for contributing. You'll probably have more information on where to find things in the prompt. You're going to have to couple this agent tightly to your repo. Unless you've completely, your development practices are completely ubiquitous across all code bases, which is rarely the case. Okay, I'm going to quickly get through here. Lastly, I guess I'll show you the agent prompt if that would help. But we're creating a strands agent. We're using reasoning low. You could use high. High is going to take a while. It's also going to be generally more expensive because you're using more tokens to arrive at the answer. So let's take a look at the prompt. And then we're at like just under 4 minutes left, so I'll try and go through this quickly. And I'll do word wrap here so we can actually see. Yeah. So you are an enhanced planning agent with GitHub issue validation capabilities. I'm sort of telling it what an issue is. Determine whether it's a bug or a user error, because a lot of issues are like, yo, go check the README. Like, this is the wrong way to use it. So validating whether this is a legitimate issue or if it's a feature. You can imagine too, these are tracks you might go down where you're going to handle features completely differently, right? Or you're going to handle bug fixes with some level of urgency and assessing the urgency of the issue. But again,
and I want to call this out too. Like, we might notice models really love the users, right? And if we have an agent that's just going to go and change the repository every single time the user makes a mistake, and it's just not using things correctly, that'd be way out of hand, right? We don't want it to do that. And so, it is like an important consideration because A lot of times people, I don't know if you guys are managing any open source repos, but they might be commenting things all the time that are just, that's not how you do this.
Yep. We have some repositories from SAs at Amazon who are already managing their repository in this manner. So I can send you an example.
Wait, we had a question too.
Oh, yeah.
Basically, what you are doing is coding another team member of the team, which will be responsible for resolving some specific task that you are assigning to it.
Right.
Perfect for the manager.
Yeah, there's some dynamism here, though, that changes over time, right? Like if the things that you bake into your prompt, you're going to have to keep revisiting this. We haven't even talked about agent evaluation, which is analogous to employee performance evaluation, right? So not sidestepping all that, but yeah, a lot of it is very analogous to that. Yeah.
So the question is if you can do this when a PR is submitted. I think I would see a different application maybe when a PR is submitted doing a code review or things of that nature. I think what we're looking at here maybe is like almost reactive to specific issues that are opened on a repository. Something is reported as a failure. How can we go and create the PR that would have the fix and then have the human go and kind of do the review and merge it?
Yep. Yep.
Okay. We are out of time.
Yeah, we're more or less at time. I think probably a good place to stop. Any questions? Yeah, go ahead. Sorry, say that again? Yeah, we'll publish the repo for this code. Yeah, we'll make it available.
Yes. Yeah, we can do all of that. We will do that.
We're just going to push it to the LangChain repo and just.
No, just kidding.
Kidding. Yeah, well, thank you for joining, everybody. It's been an absolute pleasure. I'm sorry we had the technology issues, but good
if you
luck.
have, we didn't, the point of this wasn't to go too much into the features of the Nova models, right? It's not a breakout session, it's talking about the code. If you have questions about any of the new releases, the quick PSA, we have a booth at the expo, people there all the time that can answer questions. But yeah, I hope that you got some value out of this and had a good time. I appreciate it.